This video clip is part of the EPFL introductory course on information, computing, and communication. It is the second in a set of video clips on memory hierarchies and management. It introduces the fundamental concept of memory hierarchies. As shown on this graphic, plotting storage device capacity against performance, the larger capacity a device offers, the slower it tends to be in terms of latency. As also underlined on the slide, RAM technology is the only one that is capable of approaching the performance requirements of modern processors. Yet RAM technology comes at a prohibitive cost, and thus the amount of it one can typically afford is limited. Furthermore, RAM technology is volatile, so that all information it contains is erased when the computer is powered off. These cost, size, and volatility limitations are a major hurdle that must be overcome to build computers that are fast enough and offer enough storage capacity, yet are affordable and retain all information when they're powered off. The trick to get around this challenge is to design computers as sitting at the top of a memory hierarchy, where the higher layers provide limited amounts of expensive but fast memory, while the lower layers provide unlimited amounts of cheap but slower storage. The high levels are then managed to always keep in them information that is currently in use by the computer, by the processor, while leaving in the lower storage layers information that is not currently needed. At the top of the memory hierarchy, every modern computer thus provides some small amount of very fast random access memory called cache memory, which sits inside the processor chip. Just below that level, the memory hierarchy always includes still limited size and volatile, but larger, somewhat slower, and less expensive main memory off of the processor chip. Then comes non-volatile storage, which is no longer called memory actually, in the form of solid-state devices, flash and or hard disk devices. Some computers then come with an additional slower, cheaper, sometimes larger, non-volatile, removable storage layer using technologies such as flash, CDs, DVDs, or magnetic tapes. The present set of video clips focuses on implementing the volatile part of the memory hierarchy, in red on this picture, which is automatically managed by the computer hardware. The set of video clips in the next lesson of this course will focus on the implementation of the non-volatile storage part of the hierarchy, in blue on this picture, which requires more explicit management actions on the part of users and their software. To understand the basic concept of how a memory hierarchy operates and why it happens to work, compare it to what happens when you go on a trip. At home, you have a house full or a room full or at least a cupboard full of your clothes and other belongings. But you never take all of that with you on a trip. You take along only what you know you will need for that particular trip. And when you come back, you empty your suitcase and put things back into the cupboards where they belong over the long term. Similarly, with respect to information, you may have at home a powerful desktop or laptop computer containing all your files, music, photos, and films. Yet when you leave home for the day, there is no room to put all of that in your mobile phone. Thus, on your phone, you take along only what you plan to use, listen to, or watch during the day, knowing you can download more on the way if you need to. Inside computers, or your tablet or phone, hierarchical memory is managed in exactly the same way. The computer and its software manage to import into main memory and cache only what it currently needs. The rest of the information remains in the lower levels of slower but larger, cheaper, and especially non-volatile storage. That way, information is never lost if and when the computer, tablet, or phone is powered off.